Hello and welcome to the live broadcast of Rocket Lab's 7th Electron mission, the Make It Rain mission for Spaceflight. It's the afternoon of June 29th down here in New Zealand, and we're approximately 20 minutes away from liftoff out of Launch Complex 1 on the Mahia Peninsula. My name is Max Muncy. I'm part of the launch operations team at Rocket Lab, and I'm joined by the mission control team right here in Auckland. So we're excited to have you guys join us for yet another Electron mission. Before we get into the details of today's mission, we'll take a quick look back at our most recent launch. Just last month, we launched That's a Funny Looking Cactus for our friends over at the Space Test Program. Other than being Electron's first night launch, it was Electron's heaviest to date, with a total payload mass of around 180 kilograms. So let's watch the replay of that amazing liftoff.
4, 3, 2, 1.
First motion.
And what a beautiful launch it was. The mission also maintained Rocket Lab's heritage of mission success and brought our total count of satellites deployed up to 28. Tonight's launch will take that count into the 30s. The sun's about to set in New Zealand, but Electron is vertical and ready for flight. At the moment, we're just waiting for the launch director's final go, no-go poll, so let's listen in to hear if we are go for launch.
Okay, and all stations, this is flight on mission court. Stand by for final poll for launch. RCO.
RCO's go for launch.
LD.
LD's go for launch.
And executive.
Executive is go for launch.
Roger that, thank you.
You heard it, folks. The launch director has given us the go for launch, so we're just about 14 minutes away until T0. Liquid oxygen filling procedures began at around T-minus 2.5 hours, so now both of Electron's stages are fully fueled. Those white stripes that you see around Electron indicate where the chilled liquid oxygen is icing up over the vehicle's black carbon composite structure. Today's mission is Rocket Lab's 7th Electron launch overall and our 3rd for 2019. The mission was procured by a rideshare provider called Spaceflight, and it's Electron's first commercial rideshare mission since our 3rd launch, which was dubbed It's Business Time back in November of 2018. We've called this mission Make It Rain in a nod to just how much it rains in Spaceflight's home city of Seattle. So approximately 12 minutes from now, Electron will lift off, carrying 7 satellites to low Earth orbit, including Black Sky's Global 3 microsat, 2 Prometheus satellites for the U.S. Special Operations Command, and also a few others. One of these is actually a student-built CubeSat, the Acrux-1 spacecraft, which was built by students of the Melbourne Space Program. This means we're launching government, commercial, and educational payloads on this flight. So we're thrilled to be opening access to space for such a diverse set of customers. For a little more about the payloads we're flying, here's Spaceflight.
Spaceflight's mission is to make space accessible for everyone. We hope organizations get their satellites on orbit by offering rideshare and mission management services for small satellites. We work with nearly all launch vehicles around the world, which gives our customers greater flexibility, minimizing the negative impacts of delays, especially valuable for organizations launching multiple spacecraft. Our rideshare service makes launch easy and affordable, lowering the barriers to entry and ensuring you can get to space on time and on budget. We're excited to be adding Rocket Lab's Electron to the list of launch vehicles we work with. The Electron allows small satellite operators to get on orbit quickly. This upcoming launch will be the first of many launches with Rocket Labs. This mission, appropriately called Make It Rain, will bring huge opportunities for our customers. It's a rideshare mission carrying 7 satellites from Black Sky, SOCOM, Swarm Technologies, Melbourne Space Program, and others. We're excited about our partnership with Rocket Lab and for their regular cadence of launches. So thank you to Rocket Labs from our Seattle headquarters. And now, let's make it rain.
Clamps open. Proceeding with strong back retract.
VMS flight on mission code.
Go ahead.
Please confirm all separation events are armed.
All separation events are armed.
And RF flight mission.
Go ahead.
Confirm the S-band has been switched to high power.
Confirmed.
So now we're approximately 10 minutes until launch, and you notice that the strong back has started retracting from Electron. This structure supports the vehicle while it's upright, but it's retracted shortly before launch to clear the way for Electron's 9 Rutherford engines at liftoff.
Flight avionics mission.
Go ahead.
HVBH fans are disabled.
Copy that, and heaters.
And heaters.
Thank you.
Flight buffer mission.
Go ahead.
Camera recordings are recycled.
Thank you. Avionics flight on mission.
Flight avionics.
Please confirm the stage 2 battery hot swap is ready.
Stand by. Flight confirming hot swap ready.
Thank you, and confirm stage 2 HVB1 and HVB2 are enabled, and HVB3 is disabled.
Now, if you've watched Rocket Lab launches before, you're no stranger to our kick stage, but what you may not know is that it formed the basis of Photon, which is Rocket Lab's newly announced satellite bus. Our mission has always been to make dedicated, frequent, and reliable access to space a reality for small satellites, but launch was just the first step in that mission. Today, we're not only launching small satellites, we're designing and building them as well. With Photon, small satellite operators can come to us with just their sensor, payload, or even just an idea, and then we'll take care of the rest. We'll build and launch a satellite to their unique specifications that can support missions in low Earth orbit for up to 5 years. Enough from me, though. Let's hear about Photon directly from the head of the team that's bringing it to life.
My name is Grant Bonning. I'm the Chief Engineer for Space Systems here at Rocket Lab. The canonical way that people have done space missions in the past has been they go out and they buy a payload from one vendor, they'll buy a satellite platform or bus from another vendor, they'll buy a launch from a third party or sometimes through an intermediary or a broker, and it's like herding cats. You've got to pull all of that together into a program. It becomes very expensive, very difficult, and you lose focus on the thing that actually matters. By being a one-stop shop for launch and a satellite platform, we can really help customers hyper-focus on the part of their program that makes them money, which is their payload. We can take care of pretty much the entire solution for people, and that simplifies dramatically how they go and procure space missions. The third stage, the kick stage of the Electron launch vehicle, is a really impressive vehicle all by itself. The next logical step for us is to incorporate power generation capabilities and augment it in a few other ways to turn it into a fully featured satellite. And that's a relatively straightforward step that had always been part of the master plan for Rocket Lab. So right now, by evolving our kick stage into Photon, we can offer really a huge amount of configurability for customers depending on what they need. Photon can carry a wide range of different instruments and payloads, anything from telescopes that can take pictures of the Earth, weather monitoring equipment, even to do space-based internet access for people. And in support of that, Photon offers a wide range of different subsystems and configurations. But in general, it gives radiation-tolerant avionics, extremely high-precision attitude control or spacecraft pointing, high-power generation capability, a great propulsion system, and overall the ability to communicate that data that an instrument or a payload generates down to the Earth at very high rate. People have been talking about operationally responsive space for decades, and now it's actually here.
Thanks, Grant. Rocket Lab's future is certainly going to be interesting with the addition of Photon to our lineup. Now, being situated on a Pacific coastal point, New Zealand's Mahia Peninsula is a beautiful spot for Electron to launch from. But we're also incredibly excited to soon be able to call Virginia, USA, our second home for launch. Construction on Rocket Lab's Launch Complex 2 at the Mid-Atlantic Regional Spaceport, or MARS for short, is on track for completion later this year. So technically, we'll be launching from Mars soon. While Launch Complex 1 in New Zealand will always remain our high-volume launch site where we can launch up to 120 times per year, Launch Complex 2 can support up to 12 launches a year and is tailored specifically for government missions. So we can't wait to bring Electron launches to United States soil.
Thank you, RCO. FSO flight on mission.
FSO go.
I can confirm the FTS is on internal power. Check tone should be up continuously from now.
Copy.
FSO, please enable FTS failsafe and confirm.
FSO copies. Failsafe has been toggled.
Copy that, and FTS flight on mission.
Go flight.
Please confirm FTS is green on internal power.
FTS is green and go for flight.
And all stations, this is flight on mission. From now there should be no red flags on your LCCs.
FSO RCO mission cord.
This is FSO.
Confirm flight safety is green.
Flight safety is green.
Copy. All stations on mission, range is green, auto sequence is armed.
Copy, RCO.
So we're at around T-minus 3 minutes until our target liftoff for today's Make It Rain mission. So I'm going to hand it over to the team in mission control and we can follow the remainder of the count.
Flow, this is flight on mission cord.
Go flight.
Please disable power pack HVAC and confirm.
Stand by. Power pack HVAC is off.
And LD flight on mission.
Copy.
Vehicle is ready.
Okay, copy. VMS, LD on mission. Go ahead. Please confirm flight computer ASGO are green.
Flight computer ASGOs are green.
Okay, and please lock the sequence and confirm.
Auto sequence is locked.
And to all operators, we are go for auto sequence start at T-minus 2 minutes.
Avionics flight on mission.
Flight avionics.
Please confirm all AV bats have been switched to internal power.
Vehicles on internal power.
RCO flight mission.
Go ahead.
Confirm ground power is disabled.
All ground power's down.
Roger that, and all stations, be advised vehicles now on internal power.
Pressing locks.
PLS flight
Kiro.
mission.
PLS copies.
Please disable anti-geysering and confirm.
All stage anti-geysering is disabled.
Copy that. Stage 1 flight on mission.
Flight stage 1.
Please confirm stage 1 is pressed.
Stage 1 is pressed.
High flow engine purge.
Stage 2 flight mission.
Flight stage 2.
Please confirm stage 2 is pressed.
Stage 2 is pressed.
Commanding deluge on.
Deluge running.
Readying GNC systems. Re-readying engines.
Ten, 9, 8, 7, 6, 5, 4, 3, 2,
Ignition.
1.
Lift off. Vehicles clear the pad.
And we have liftoff of the Make It Rain mission on Electron. Shortly, the vehicle will come up against max Q, or maximum aerodynamic pressure, where the forces against Electron will hit their peak. So let's listen in for that call.
IP tracking downrange.
Coming up on maximum dynamic pressure. One minute, stage 1 remaining.
Stage 1 propulsion remains nominal.
Shortly, Electron will go through a series of major milestones in quick succession. Starting with main engine cutoff, or MECO, the 9 Rutherford engines on Electron's first stage will shut down in preparation for our first of 2 separations. Following the separation of Electron's first and second stages, we'll see ignition of the vacuum-optimized Rutherford engine on Electron's second stage. Electron's second stage, carrying the kick stage and its payloads, will then continue onto an elliptical orbit.
Power pack CO2 succeeded. 15 seconds remaining. Entering stage 1 burnout detect mode.
Stage 1 Miko.
Stage separation succeeded.
Stage 1 Miko.
Guidance is nominal.
As you just saw and probably heard from the applause, we have had main engine cutoff. Electron's first and second stages have successfully separated from each other, and the
Fairing
Rutherford
separation
engine on
succeeded.
Electron's second stage has ignited. And there goes the fairing. The fairing protects the payloads on the way to orbit, but once we're out of the thicker parts of the atmosphere, we don't really need it anymore. It's just been successfully jettisoned to make way for payload deployment approximately 51 minutes from now. So we've got a couple minutes until our next milestone coming up, but our trajectory is looking nominal and Electron is tracking for a successful flight.
Trajectory remains nominal.
Stage 2 propulsion remains nominal.
Just checking in with you guys again. Everything is looking good from mission control, and we've got another 90 seconds before the battery hot swap. So we're now at T plus 5 minutes and 45 seconds after liftoff, and like I said earlier, the next major milestone coming up is the hot swap of the batteries. If you've watched our launches in the past, you'll be familiar with this process, but if you're just joining us, I'll give you a quick rundown. The Rutherford engines replace traditional gas turbo pumps with electric ones powered by batteries. Once these batteries have depleted of energy, they're really just dead weight. So to solve this problem, we perform a hot swap where we transfer power over from the depleted batteries to another fully charged one, and this provides a much more efficient ride to orbit. So our team will make this call soon, so we'll listen in.
Coming up on HV battery hot swap. HV battery eject succeeded.
Stage 2 propulsion is
So as you just heard, we've had successful hot swap of the depleted batteries. Stage 2 propulsion is nominal and our trajectory continues to look good.
.100 seconds remaining. .1 minute remaining.
Entering stage 2 burnout detect mode.
Alright, a quick recap of the Make It Rain mission so far. So we've made our way through a successful ignition and liftoff, stage 1 burn and separation from stage 2, fairing jettison, and now the battery hot swap. So right now we're waiting for the second stage as we get closer to the engine shutdown ahead of the kick stage separation. So back to mission control audio for the next mission milestones.
.20 seconds remaining.
Stage 2 engine cutoff.
Transfer orbit is nominal.
Interstage separating.
As you just heard there, we've got confirmation that the kick stage has separated from Electron in the lead up to payload deployment. In around 45 minutes time, Make It Rain's payloads will be deployed individually from the kick stage at predetermined intervals. So for confirmation of this payload deployment, and of course to watch videos from liftoff, stay tuned to Rocket Lab's social media channels. Now with 3 flights under our belt for 2019, it continues to be a busy year for us. We've got frequent launches scheduled, the Photon program is cycling up, and construction on Launch Complex 2 is in full swing. This growth means there are some awesome career opportunities here at Rocket Lab. As part of our team, you'll work on technology and missions that are launching right now, not in years to come. We've got roles in Auckland and Mahia in New Zealand, as well as positions at our headquarters in Huntington Beach and also at Launch Complex 2 in Virginia. There are opportunities across the company, from our composites team, which manufactures Electron's carbon composite structure, right through to our mission management team, who work with our customers to streamline every step of the way to orbit. We're also looking for software engineers, avionics techs, and vehicle test engineers. At Rocket Lab, every voice counts, every idea can be explored, and then everyone contributes directly to our success. So make sure you check out some of the open positions on the Rocket Lab website. So just before we end the webcast, we have to give a shout out to one of our biggest fans, budding rocket engineer Elliot Weritz. Stick with your dreams, keep building rockets, and we'll keep a seat ready for you in mission control. So with that, we'll be ending today's webcast of Rocket Lab's Make It Rain mission. A special thank you to our mission partners for choosing to launch on Electron. So from all of us here at Rocket Lab, thank you for joining us for our 7th Electron launch, and we'll see you guys here next time. This is Rocket Lab Mission Control, signing off.